Oh. So let's see. Okay, recording is started. So welcome to today's tutorial. So let's go through the practical. Uh, so the Utopian Department of Health is contracted you to develop an SRI, susceptible, recovered, uninfected. I think this was a semester test. Wasn't this a semester test? Yeah, I remember, or maybe it was a practical. I remember this question paper. So, based on epidemic modeling software system to better prepare for such situations in the aftermath of the event, an SRI model consists of modeling the random motion of people who are classified as being either susceptible to infection, recovered from infection. Okay, so it can be susceptible, recovered, or infected. Okay, and as you can see, they said random motion of people. So basically, I think it's going to be random movement from from that from that paragraph. Talks about random motion. So this is the game. We have susceptible, which is the white circles. There's ones, the white circles. There's ones, the white circles. Okay, I think yeah, the white circles. And then recovered, there's the double circle. Double circle. Where is it? Okay, there's ones, there's a recovered. And then we have infected, which is the black dots. Then infectious radius, which is that circle. Your logic must be placed in the SRI namespace. Okay, so let's do that. So let's create our project. Um, okay. Oh, I installed a different IDE. That's why it's not showing past practicals. So I'm not sure. It's tutorial what now? It's tutorial 16, right? Yeah, 16. So it's tutorial 16. So tutorial 16, computer science, science 1A. Okay, so let's add our files. Okay. No, no, no. Okay, so let's add our files. So I'm gonna create a new header file. Uh, wait, where is it? New file. Wait, it's not. Okay, let me do this. Let me right click. Why isn't it showing anymore? It should be showing the header file part, the source file, and uh, okay, let me try this still. Okay, let me just say new file. Um, but wait, if I just say new file, it won't add those things at the top. Control package. Why isn't it showing anymore? You manage ID settings. Okay. Don't tell me there's an old version here. Okay, let's just wait for it. I don't know. Seems like it's still loading. Let me just fix something real quick. Users, then C. It's supposed to be Sea Lion. Okay, no, not here. I think it's on programs 86. Okay, it's not there. System program files. C Lion. Where is it saved? Manage ID import settings. Oh, it's inside JetBrains. And so, yeah, inside JetBrains. Wait, inside JetBrains. Okay, so let's do this. And then J. Okay, it's not showing. Supposed to be adding the files here. Okay, there it is. It was still loading. Okay, so let's start. So I'm gonna say using namespace standard because I don't want to write this in my code every time. I want to use a tool from the standard namespace. So now I'm going to say the source file. Okay, doesn't really matter which file you start with. And then I'm gonna have a header file. Okay, we have that. And then I'm gonna create a namespace called SRI space. And then in the source file, I'm gonna import hash include SRI space.h, and then namespace SRI space. And then in my main, I'm going to use that namespace. In my main, I'm going to use the namespace. So I'm going to say hash include SRI space.h to include the header file. And then I'm going to use the namespace because this is the client. The main is the client. All the client does is use features that we've created for the client. The CPP file and the header file, that's the back end of the development. So it's only code that's seen by developers. So here I'm gonna add IOStream, and then I'm gonna add C standard library, and then I'm gonna add the CTime library, and then I'm gonna add the string stream, and then let me see, is that all? Yeah, I think that's all for now. So let's see, let's look at our game. So in our game, it's a non-player characters. So that means non-player, so that means there's no player. We just have like characters. So for example, you could say instead of having like a player that moves, that does this, does that, this and that, we just have features in a game that just move randomly. So they will move what? Randomly. Because as you saw in the introduction, it says an SRI model consists of modeling the random motion of people who are classified as being susceptible to infection, recovered from infection, or infected. So these are actual people, right? But the movement is going to be randomly. It's going to be a random movement. So we're gonna take in the size of the environment. So before we do that, let's create our arrays, right? I'm gonna create an array called, I'm gonna define a type for it. So type def to the array, and then I'm gonna create a structure, enums and so forth. So let me start with the enum for status code. The enum for status code, you're gonna start with success. Okay, since it's a status code, let me start with the errors. So I'm gonna have error converting to int. So there's an error with converting to int. So I'm going to make it start at some negative value. For now, I don't know how many constants I'm going to have in this enum, so I'm just going to leave it blank. So I'm going to have error convert, and then I'm going to have error count. There's an error with the argument count, and then you can have error in error range. Yeah, I'm just going to call it error range. So it increments by 1 at every single stage. So how do I get the starting point? Because I want this one to be equal to 0. So that means this one needs to be a negative value. So basically I start counting backwards. So I forgot a comma there. I start counting backward. So start counting backward from 0 and you're moving backwards. So that means you're moving to the negative infinity. So this becomes -1. This becomes -2. Then this one becomes -3. That's going to be my starting point. So it's going to be -3 because at each turn it's going to increment by 1. So -3 plus 1 gives you -2. -2 plus 1 gives you -1. -1 plus 1 gives you 0. And then I'm gonna have an enum. Okay, before I do that, let me just update here and set this one to success because I have a constant for it. So I'm just going to set that to success. Okay, why is it morning? It's not declared. Yeah, I don't know why it's doing that. We'll get back to that. So I'm gonna need an enum for movements. So I'm just gonna start with an E movement. I start with an E so that I remember. Wait, it's random. Okay, it's random. So we won't need an enum for movement. We won't need that. Wait, let's see. Let's look at the movement. Each character can move 1 step in any random direction. May not leave and so forth. Okay. Yeah, we're not gonna need an enum for that because you need an enum when you are going to get the input. So when the user types the movement and says, I want to move up, that's when you'd create an enum for that, right? So you'd say enum, E movement. You start with an E2 so that you remember that it's an enum. So enum, and then you'd have constants representing the movement. So you'd have move up, you'd have move down, you'd have move left and right, and so forth. But in our scenario, or in the problem statement that we are given, they said the non-player characters will move what? Randomly. The non-player characters move randomly. So they move randomly. The movement won't be determined by the user. It's going to be determined by the random function. So I have that. So let me just do this. Let's create a structure, right, for our game world. So I'm gonna have a game world structure like this and put every feature that represents my game world. So what are the features that represent my game world? So it's the size of the environment, right? But before we do that, there's also what? An array. Before we add the things that are in the question paper, there's also what? An array, because this is a what? It's a 2-dimensional game, or it's a 2-dimensional plane. So it's even given here, it's a 2-dimensional area. So I need to make use of a 2-dimensional array. So that means one of the features of my game is that it's a 2-dimensional, it's 2D. How would I represent that? I would use a 2-dimensional array of integers. So I would say I already defined a type def, so I'm going to say rect 2D, the name of the type def, and then I give it a name. Okay, no, this is it's in the wrong place. I should say, let's just call it array world. Yeah, let me use a different term. Let me just call it array world. And then, so now we start looking at the requirements of the question paper. So you need to put the size of the environment. So I need to put the size of the environment. It's 2D. So I have rows and column. Basically, since it's 2D, it's like if you think of a Cartesian plane, it has X and Y, right? So you can imagine the rows being like your X's and then your columns being like your Y's. So it's going to need two values to store the size of the game. And then I'm going to have a chance, infection chance, and a chance is a percentage basically. And we're just going to use an integer for the chance. So I'm going to call it int chance, right? Infection chance. So int infection chance. And then I'm going to have a recovery chance, int recovery chance, and then int immunity chance. There's a lot of chances here. Int immunity chance, right? And then I'm going to have the initial numbers of each of the characters must be specified via the command line argument. Or via the command line, there's command line arguments. That's a lot. So it's three of them, it's three features, right? There's susceptible, and recovered and infected. So it's three. So I'm gonna need three extra things here. So I'm gonna have int susceptible, and then I'm gonna have int recovery or recovered. What do they call it? Recovered. Okay, they call it recovered, not this. And then int what's the other one? Infected. And it's what? It's the number. So I'm gonna put num at the beginning so that I remember that this is a number. Just like I put chance here so that I know this is a percentage. So I'm going to have okay, I paste randomly in there. So that's it. That's everything that I need for my game world. That's everything that I need in this record structure. So now what I'm going to do is I'm going to create the functions. So functions, the first function is int. It's a function that returns an integer to convert to an int. So it's a convert to int function, which is going to take in a string. Remember, I didn't say using namespace standard there. So I need to specify which toolbox which toolbox am I getting this tool from? So standard : and then I want the string tool. So it's going to take in a string value, and then you're going to have a create world function, which is going to return your game world. Create world, which takes in all of these things from int rows up until int num infected, which takes in all of these inputs. So it's going to be a bit untidy, but I don't want to type everything. So I'm just gonna do this, then comma, then do this, then comma, then do this, then comma, and then do, yeah, this is a lot of things to input. And then comma, yeah, it's a lot. I have to really zoom out in order to see everything. Int num susceptible, and then int num recovered, and last one is int num infected. And then I need to remove this semicolon here and put it there. So that's everything that we're going to need from the user. We're gonna need up until the num infected. So we have everything. So basically the create world, it takes in all of these things that are here. Everything in the first bullet. Everything in bullet number 1. That's what goes that's what goes into the function as input. The create world function. Then I'm gonna have a print world function, which just returns a void. So print world function. It's going to take in a game world, rec world, because game world, remember, is the name of a record structure. So I'm gonna put a prefix rec there so that I remember that this is a record structure. And then I'm gonna have void delete what should I call it? Okay, let me just say delete memory. So since I'm deleting memory, that means I'm making changes to my game mode, right? My game mode structure. So I'm going to say this, take it by reference, because I'm making changes that should be permanent. I want permanent changes. So I have the functions, and then before we continue, I forgot to put in the CAsset library because I'm gonna need to check ranges, right? So here I'm gonna define a constant max size because our game needs to have error handling, right? So I'd say the maximum is going to be 100,000. That's the max size. So we're gonna use that as the max size. So if a user enters a value that exceeds that value, then we need to notify the user, output an error message. And then I take in all of these functions. Okay, I'm not missing any function. Okay. So I take in all of these functions and then I replace the semicolon with 2 curly braces because now I'm going to provide the implementation for each function. Right? And then now, since I'm going to write code here, there's an implementation file. I'm going to say use a namespace standard. So let's create the generate random function, generate random, which takes in a lower value, starting point. Let me just phrase it in a simple way. Int start and then int stop. Where do we start and then where do we stop? So I need to find a range. So by finding a range, you need to say stopping point minus the starting point and add a 1 so that you get the actual range. Because when you subtract the stopping point and you separate the starting point from the stopping point, it's going to be short by a 1. It's going to be missing a 1. So we always need to add the 1. If you don't add the 1, your range won't be correct. And then I'm going to call the len function inside the ctime library. And then I mod it by the range to say that I want this exact number of values to be generated. And then I say plus the starting point so that it starts from that starting point. It starts at int start. So we have that. Let's do the convert to integer. So you're gonna create a string stream, right? SS. And then you're gonna insert into the string stream the string that you want to convert. And then since we need to return an integer, remember the function returns an integer. So I need to create a local variable or a temporary variable to return the answer, to store the answer and return the answer. So after inserting the string into the string stream, look at the arrow, they're pointing into that direction. That means this is going inside the variable called XSS, which is the string stream. And then now I'm going to retrieve that string that I've stored inside the string stream and store it into an integer variable. So when it gets to this part, it then converts it to an integer. But the conversion might fail. So I'm gonna say if the string stream failed, I call the fail function .fail. It failed to convert, then what should happen? Output an error message and say failed to convert. You failed to convert what? Then you specify what you failed to convert. It's that string, which is str value. And then you specify you failed to convert it to what? So I failed to convert it to an integer. And then I start on a new line. after this error message, and then I exit the program. So it's going to be error conv int, because there's an error with converting to int. And then I'm going to return the integer, return int value. There we go. And then, okay, we are missing, okay, there's a lot that's missing. I totally forgot about that. So we're gonna need the features, right? So I'm gonna need to create an array for features. So constant features. So what are we going to say? So for me, the way I keep things simple, for my empty space, I'm gonna use dots as empty space. So let's see. Sustable, there's recovered, then there's infected. So let's just say it starts at 0, right? The array. So I'm gonna start with an empty space. The empty space is going to be a dot, and then followed by, so I also need to create an enum for that so that it makes things easier for me. So enum, I'm gonna say feature, or just say e feature, right? So I'm gonna say e feature, and then I'm gonna have an empty space. Remember, enums by default they start at 0, so this is going to be equal to 0, and then it increases by 1 every time I add a new constant inside the enum. So after this, I want sustable, and then I want recovered, and then I want infected, right? So we have those four features, including the empty space. Let's see, what are we going to define them as? So let me say a sustable is a hash symbol, and then a recovered, it's an @ symbol, and then this is going to be a $sign. The infected is going to be a $sign. So I'm going to say hash symbol there, and then I'm going to say @ for recovered, and then I'm going to say the $sign for infected, because remember the way I've structured it, I must also structure it in the same way in my array, because remember it increases by 1, so this is equals to 1, this is equals to 2, this is equals to 3. So as you can see, the nice thing about this IDE is going to show you the indexes of these features. So the dot is stored at index 0 because 0 represents an empty space. That's why I've stored it at index 0. And then sustable, it's at index 1 because it's represented by the constant integer 1. And then recovered, it's at index 2 because the constant for recovered is 2, is the integer value 2. And then infected, it's an index 3 because its constant value is an integer value of 3. That's why I've placed it as the fourth feature in the array, basically at index 3. So we have the features. I'm not sure if I need to add them here. I mean, I can, but there's no need for that. So let's see. Before I create my array, right? Okay, before we do that, remember the same thing that we did with the convert to integer function. It's expecting a variable of this type. So I'm going to create a variable of that type. Remember, game mode is a record structure, so I'm going to use a prefix of rec. So rec, and then I'm just going to call it world. So rec world. And then at the end of the day, I need to return this record structure because this function expects me to return a variable of this type. So before I allocate for the array, I need to store all of these values inside the record structure, all of those values. So I'm going to say rec world dot int rows is equals to int rows, because in the record structure, the way you access information, right? You create a variable, and then that variable the data type for that variable should be the same name as the name of your record structure. Once you do that, now you can access the variables inside the record structure through that variable that you've declared. So I've declared the variable here and it's called .recworld. So I'm going to use the recworld and say dot. I use the dot to access the variables that are in there. And then I use the assignment operator because I want to equate it to be the int rows. And these int rows are input to the create world function. So I'm getting it from the user. After getting it from the user, I store it inside my record structure. And then I'm going to do the same thing for every single thing that I take in as input inside this function. So it's equals to int calls and then recworld dot int immunity chance is equals to int immunity chance. And then let me zoom out a bit. And then recworld dot int infection chance is equals to int infection chance, and then recworld dot int recovery chance is equals to int recovery chance. I think I'm done with all the chance variables. Now I need to store the numbers. So recworld dot int num infected. Let's start with the infected is equals to int num infected. And then recworld dot int num recovered is equals to int num recovered. And then recworld dot int num sustable is equals to int num sustable. Okay, that's everything. Yeah. So this is everything that we need to store in our record structure. I've stored it. Then now I can start with the allocation. So I can allocate to the array, right? Because that's the only thing we haven't initialized here. All the variables we have initialized up until int num infected, except for the two-dimensional array. So I'm going to do that. So I'm going to say record. Remember, it's inside the record structure. So every time I want to reference it, I need to use this variable. And then I say dot, and then I access which variable inside the record structure I want to use. I want the array world. And then I say is equals to new int, and then pointer, because it's a two-dimensional array. And then I allocate for the outermost pointer first, the first one, basically. I'm going to set this to be equals to int rows. And then now I need to set each row to be equal to the number of columns, less than int rows. I mean, you can use these int rows inside the record structure because stored, you've already stored them, right? But imagine if I had to write this, it's going to be tedious. I say recall dot. That's a lot of unnecessary work for me. I can just use int rows. Because remember, I'm still inside the same function. That means I still have access to these int rows. I'm still within the same function. And then I'm going to say row plus plus to move to the next row. And then now I need to allocate for every single row, right? So every single row, how do I specify that? By passing R, of which R stores the current row. Why am I saying current row? Because I'm going through the number of rows. And then that's equals to new int. It's a two-dimensional array of pointers, right? So, but we've allocated for this pointer, so I don't need to put it there. Now I need to allocate for this one. How do I allocate memory for it? I replace it with square brackets. Replace it with square brackets, and then I specify its size. How big is that dimension? So I'm going to say int calls. And then I'm done with allocating, right? With allocating memory for the array. So before I forget the validation part, I need to validate the number of rows and the number of rows let's say the number of rows, columns. Yeah, basically everything. Yeah. I won't type everything, but it's basically everything that I'm getting from the user, because the user can enter negative values, they can enter very big values, unnecessary values. So for example, they want 1 million rows and 1 million columns. We can't accommodate that. So we need to restrict it. So there's two ways you can go about doing it. There's two ways. To be honest, the way that you would get marks for this is by creating a function called check range. That's how you maximize and get the marks. But you can still get, because you can use an assert function. You can also use an assert function to validate. The only difference is that with the assert, right? Let me see. I think with the assert, let's use it this side. So let me say int value, some value, right? This is equals to 10. And then assert, make sure. Assert basically means make sure, and then it takes in an expression, a Boolean expression. So it's basically something that can be evaluated to a true or a false. So by using assert, all you're saying is that make sure what do you want to make sure? Make sure that int value is greater than 0. That's what the assert does. You just put in a condition here, a Boolean expression. What condition should be checked? What condition should the assert function make sure of? You should make sure that, for example, an int value should be greater than 0. So we can double check that. Let's test it out. So run. It should compile perfectly. Yeah, it compiled perfectly because int value is indeed greater than 0. But let's say I want it to be less than 0, right? So make sure that int value is less than 0. What happens? You see, so assertion failed. Int value less than 0. So it tells you that it failed to make sure you failed to follow the instructions or to follow the rules of the system, that int value should be less than 0. So it failed to validate that. But you see how the error is. It's a bit vague. It's not something that's intuitive. Like, we should make a program for basically dumb people. So you can imagine, or old school people, anyone who has no clue about technology, literally no clue. That's that's what programming is all about. Okay, let me grab a charger. Okay, there we go. Okay, let's continue. So as I was saying, in programming, you just need to make sure that your program is intuitive. Like, when something happens, the user can know what really happened. You see, when it's like this, a session failed, it's a bit too advanced for people who have no clue about programming. So you can use a set, it's still fine. You can use that, but let's just make use of a function called check range, so that we describe the error. We say what is the error. For example, this value is less than this value, something like that. So let's do that. So the range, right? So it takes in an integer that you want to check, right? You want to check if that integer is in the right range. So it's within what range? So it's within int, you can say int lower and then int up. So it needs to be within that range. Some starting point and some stopping point. It needs to be within that range. And then where am I going to place it? Okay, let me place it here. So before we continue, because remember, I need to validate here. I need to call it inside my create world. I need to call it here. So I'm going to implement it first. So we do have a thing, a constant for it. We called it error range. So we're gonna use that. So how do you implement this function? It's very simple. You're going to say if int value, this value that I'm checking, this is the value that you're checking. It's going to be the first thing that gets passed into this function. If this value that I'm checking happens to be less than the expected lower, or the expected starting point, or the expected mean, however way you want to phrase it. If you want to say expected mean, int mean, it's up to you. Don't cram code and go there and be like, no, I need to only use int upper, int lower, or int max, or int min. Don't do that. Just understand what's going on and write it in your own way. That's why lecturers are able to determine whether someone is copied from another person, because there's no way people think the same. Because someone can say int start, someone can say int min, someone can say int lower. You see, there's three different ways to phrase it. The whole class, or 50% of the class, there's no way that they can all phrase it as int min, or they can all phrase it as int lower. So let's check. So if this value that I'm checking happens to be less than the expected minimum, then we have a problem. What's the problem? We should output the error to the user, inform the user what's going on. So I'm going to say that value that I'm checking, right? This value is what is less than so I'm gonna write it in full, but it is less than the expected minimum, and then you specify the minimum. What's the minimum? It's int min, and then you end the line. And then you exit the program with that error code for the error range. And then all I'm going to do, I'm going to copy this because the max is just the same thing. The only thing that changes is that I need to say greater than. So if it is greater than our maximum, that means we're out of the range. Because we're trying to make sure that this function, it checks the range. So if it happens, if this condition is false and this condition is also false, nothing happens. It doesn't output any errors. But if it happens to be true, it's going to notify the user and tell the user, listen, this value happens to be less than the expected minimum or the expected maximum. So the expected maximum int max, and then I change that to int max. And then that's about it. That's all you need to write in the check range function. So it just takes in the first parameter as the value that we're checking, and then int min is the starting point, or the minimum that we expect our program to have, and then the maximum is the maximum that we expect our program to have. Then now I'm going to call the check range function. Remember, it's a void function. It doesn't return anything. All it's doing is checking. So I'm going to call it check the range of what? Of int rows. They need to start from what? At least 0. At least 0. You can say from 1, you still can, but let's just say at least 0. We just want at least 0 because the user can decide to have no rows and no columns. That's still fine. So we can say at least 0. And then we're gonna have, what's the maximum? Remember, we have a constant called max size. So up until max size, what? -1. So that's the range that we expect. So we need to check that if the rows are provided in the right range. And then I'm going to do the same thing for my columns. Int calls, do the same thing, check the range. Check the range for the columns, and then I'm going to check the chance for each chance. So let's start with infection chance. So with chances, right? So when you look at a chance, it needs to be a percentage. So it can be between 0 and what? 100. It's a percentage, it's a chance. There's no way you can write a test and get 200%. It makes no sense. So we need to use that logic that we already have. It's from 0 to 100. And then I do the same thing here. I check for the other chances. Let's say it's what now? This is int recovery chance, right? It's the same range, it's a percentage. And then I'm going to have int immunity chance, same range. And then I'm going to verify the numbers now. So int num susceptible, susceptible, and then it's going to be in what range? Let's say between, you can have a maximum of 50. Let's just say a maximum of 50 pieces. And then check range again. No, check range again. And then int num recovered. I'm just gonna go with 50 from 0 to 50. And then check range again. Then int num. Is it infected? Okay, I think it's infected. Int num infected. And then 50. There we go. So we've validated our data. We've made sure that the user doesn't enter an incorrect value. And we defined our own asset function. We made our own asset function. So we are done doing that. We validated. We know everything is going to run well. If it doesn't run well, it's going to notify the user that things didn't go well. So all characters are initially randomly placed anywhere in the environment. So they're randomly placed anywhere within the environment. So let me do that. So let me say int c is equals to, okay, I know there's something that you might not understand, but let me just explain it. So the reason why I'm going to combine, remember that all I'm doing here is allocating, right? To be honest, it's fair to do it like this. You're done allocating, right? And then now you have a separate comment or a separate for loop, add the features, right? You can have that. And then you have, remember it's a 2D game. So I need to go through the rows and go through the columns like this, right? I can do it like this. And then I start placing the features. I start placing the features, right? But to be honest, it's a waste. You're wasting time. You already have for loops here that go through the rows. So that's why instead of separating it here, I just multitask. So after allocating, I immediately place a feature. So that's why we tend to do that. You could separate it, but you're gonna waste time. So we're just going to combine that and do it the way we've been doing it. But now you have a better understanding of why we choose to do it like this. You can do it in that way of separating, it's still fine. So let's place the feature, right? So place, what are we going to say? Okay, by default, let me say, by default it needs to be an empty space, right? Empty space by default. So empty space, I need to say record because we're using a record structure. Dot array, and then I specify the X and Y values, which is row and column, is equals to an empty space. An empty space. All right. By default. Then now, so that means every single position in my game, or every single position in my game will be occupied by an empty space. So now I'm done doing that. So now let's place the features, right? You can have a place feature function. You can. Yeah, especially in situations like this. You can have a place feature function. So let's do that, right? So I'm gonna have void place feature. So what do I want to place? So it's going to take in a game world, right? A record structure. And since I'm placing, I'm going to pass it by address. Remember, I'm placing. So I'm going to make changes to my array, and they need to be permanent. So I'm going to pass that game world record structure by reference and say game world, right? And then it's going to take in So we don't have a player, right? So we don't really care about positions and things like that. We don't really care. So this place feature function is going to be a bit different from the ones that you've been shown in the past tutorials. So place feature, after taking this, I need to take in what else do I need to take in? So here I have everything. I have the rows, columns, and the array, right? And then I need to take in the feature. So it's going to be some integer. So int feature, that's what I'm placing there. And the number of times that this feature will be placed. Because remember, excuse me, remember that we have what is this? Where is it? Yeah, the initial numbers of each type of character. So we have specific numbers. So let's say the infected, you can have 3 infected features, you can have 3 recovered features, you can have 3 sustable features. So there's more than one. It can be from 0 to infinity. So I need to also take in a number, int num times. So basically a number of times this feature will be placed. So it takes in the array of which is stored inside a record structure. And the record structure also has the rows and columns and everything. So I don't have to pass them there. And it's going to also take in a feature. After taking a feature, it also takes in the number of times. But to be honest with the feature, right? To be honest, let me think about it. Is it necessary to? Okay, yeah, it is. Yeah, it is. Yeah, just pass the feature. Yeah, it is important. So int number of times, right? So what I'm going to do is remember this code of placing the feature, it needs to be repeated for a specific number of times. So I'm going to say int just say t, that's the variable. So start at 0, and then t is less than int num times for the specific number of times. There we go. And then what are we going to have now? So yeah, we're going to generate a random row and a random column, right? But I really don't like this, but okay, it's fine. Okay, it's fine. Okay, it's fine. Let's just do it this way. So I'm going to generate a random row, right? So int row is equals to generate random from row 0 up until int rows. Okay, it's inside the record structure. So I'm going to say record.int rows, right? -1. Since I'm counting from 0, I need to stop at the number before. So I'm going to say -1. And then int column is equals to generate random from 0. And then I pass in the columns, of which the columns are inside the record structure. So I need to pass in that variable of type record structure first. And then I say dot to access the number of columns. Int calls -1. Right, we have that. Yeah, we are moving. So now I need to say while, I need to do a while loop, right? Because, okay, to be honest, yeah, to be honest, this part here. Yeah, I don't want to sound rude or anything, but that part, writing that code is is stupid because look at the range. You have a range there. It clearly takes care of everything. That's the range. You don't have to say, for example, rec world. I've seen this a lot of times. So you take in the row and then you take in the column, and then you say, it's not equals to an empty space, right? So you make sure that it's within the world, basically. But I mean, duh, you're passing a range there from starting to stop. So it is going to be within the world. So I don't need to have this while loop because it's only going to generate a random value within that range. And the range is going to be the size, basically the size of our game mode. So there's no way we're going to place a feature. There's no way in hell we're going to place a feature outside of the world because we stated the range. There's no need for that there. So now all I have to do is what place the feature. So I'm going to say rec world dot array world. For that randomly generated row, which is int row, and that randomly generated column, which is stored in int column, and equate that to what? That feature, which is int feature. Then there we go. But I think we might have to switch it up a bit, like change this function. Yeah, I think so. I think we might have, let me see. There's many ways you can approach this problem. That's the thing. I want to find the most efficient way, because we also need to validate and make sure that we don't place features on top of each other, right? That's what I'm thinking about right now. So let's start. Let's place the suggestible. Let's place the suggestible feature. So I'm going to call the place feature function, place feature, right? Takes in that this rec wall, this record structure, and then what feature is it going to place? Suggestible, and then how many times? It's int num suggestible, right? And then it's going to place the features. But now, the reason why I'm saying we need to kind of like change it a bit is now how are we going to validate and make sure that we don't place features on top of each other? Because now I don't have the main point I'm trying to say, I don't have the row, I don't have a column. So I don't know, I can't keep track of where they are stored every single time. So to be honest, we need to change that. So let's do that. Let's add so we're gonna keep track of the row and the column. So int row and int column like this. But these columns need to change, right? They need to be updated. So I need to pass them by address. Because as you can see, I have the assignment operator, which means that I'm saying this is equal to something, right? So whatever value I'm going to pass in here is going to be changed. So that's why I need to pass it by reference. And then since we have, let me think, for those number of times, okay, I don't think, yeah, I don't think it's going to be necessary to take in the number of times. Let's just place the feature. Let's just have this function. Yeah, let's just have that function. And all it's going to take is the feature and the coordinates for that feature, the row, column, and the feature itself. That's all you're going to place there. And then we come here, we start placing, right? But remember this placing, remember this code, this place feature function. How many things am I placing here? I'm only placing one feature. So this place feature is going to be inside a for loop. So this is where I've decided to put that for loop. So int t is equals to 0, and then t is less than, okay, int num suggestible, and then t plus plus. And then I'm gonna have a row here. I'm gonna have those rows now. Those variables that keep track of every single feature that I've placed. So now I'm going to place the feature. I have to place the feature, pass in the record structure first, and then it's followed by a row and followed by a column. Then the last thing, as you can see here, it shows me the structure. The last thing is is the feature. What's the feature? Is suggestible. That's the feature. And at this point, right, it can overwrite the empty spaces. It can replace the empty spaces because that's the point. If I don't replace the empty space, I'm not going to have any feature on my game. So at this point, I'm not going to validate and say, please don't place on top of this feature, because at the moment, what do we have? We only have an empty space. So I don't have to worry about that. And then after this, now we place the infected. Place the infected. And then I'm going to have a for loop. Okay, I'm not going to repeat myself. I'm going to have a for loop there, which is the row and the column, right? but I can't place this infected on top of suggestible. So that's why it was important for me to have this row and this column so that I can use that to check if for that specific coordinate that I've generated, that random row and column, is it already occupied? And I'm going to use a while loop because it's randomly generated, remember. It might randomly generate the same coordinate, and I don't want that. So I'm going to access my array, which is inside the record structure. And then I say for that generated row and that generated column, that random row and random column, while I generate and it keeps being equal to a successible, that means I need to place the feature again because I don't want to place it on top of a in the same location as a suggestible feature. And I need to change this to infected because now I'm placing infected there. Okay, no, I need to do this, copy, paste, and then there we go. Yeah, that's good. So now I also need to check I need to place the other feature, right? So what I'm going to do is I'm just going to repeat this code, copy, and then we're going to place, what's the other one? There's infected recovered. So place the recovered. So let's place the recovered. Oh, yeah. This thing of copy and pasting, you'll forget, you see, it's int num suggestible. So see int num suggestible there. So I'm going to say int num infected there. And then here I'm going to say int num recovered. Yeah, copying and pasting it's not always safe. So let me say, let's change this to what recovered because that's replacing a recovered feature. And remember that each space can occupy one feature at a time. So if it can occupy one feature at a time, I'm going to use the OR operator here. I'm going to say if the random row and column that I've generated, it it's occupied by basically is that's why I use that's what the two equal signs mean. It means that it's occupied by or it's equals to, it has that feature. What feature is it? If it's what infected. If I happen to try to place on an infected feature, place the feature again, regenerate. And then we've placed all of the features. We are done with the create world function. Yeah, it's a lot. I know it's a lot, but yeah, as long as you know your logic, you're not gonna go wrong. So let's print the world. So I'm going to say system. Remember that I want it to clear every time I print, right? So I'm just to say system and then say clear, semicolon. And then I go through the number of rows inside of my rec world, and then dot int rows, row plus plus to move on to the next row, and then int column started column 0, and then columns less than the number of columns which are inside the record structure, C++ to move on to the next column. So now I need to display the features, right? So it's just simply saying cout, but I need to get the integer value for that feature. Remember, I'm using constants to represent my features, right? I'm using these constants. So I'm going to retrieve each constant, and remember each constant is stored in what? In a two-dimensional array. That's the whole point of having that two-dimensional array. There it is. So I'm going to reference that two-dimensional array. So I'm going to say cout. Yeah, it's going to be quite long. It's a bit long. So features, that's my array, right? I'm going to pass the index or the integer value. Basically, that means I need to pass the constants. So I'm going to say record.myArray, then for the specific row and specific column, and then output a space, okay, space, and then after every single column, output an end of line character. Okay, and then yeah, and then now we need to do the delete memory. Okay, just give me a sec. I'll be back. Just give me 2 seconds. Okay, I'm back. Sorry about that. So let's continue. Let's do the delete memory. So we're deallocating. So when you deallocate, remember the structure is like this. You say delete, and then the container that you want to delete, and then followed by that the name that has that contain, or the variable that has that contain. But we're going to use an asset, right? So this asset, right, it basically makes sure, remember an asset, it's a make sure function. So make sure that array world is not equals to now pointer. So that means it's not array, it's not empty, because we don't want to, there's no point in being redundant, emptying out an array that's already empty. There's no point in doing that. So I'm going to use that asset function. And then I'm going to go through the number of rows, because the way you deallocate, right? The way you deallocate is you sort of like do the vice versa of allocation. So if you allocated the rows first, you're going to delete the columns first, and then you delete the rows after. That's how it works. So I'm gonna go through the number of rows, row plus plus, and then I'm gonna delete the columns for every single row. So delete the columns container, or the columns dimension, from what rec world dot array world for every single row. Which it's just that the syntax is a bit weird, but yeah, it's basically saying this. For that container, remember this container is a container for columns, right? So basically it's saying emptied out. That's what it means. Delete, use the delete keyword to say make it empty, and you leave it empty like this because you're emphasizing that you're deallocating. Remember the first time we used the keyword new, if you remember new, to say that it has this size. That's what is expected when you use the keyword new. You need to put a size. Now we're doing the vice versa. So I'm not putting anything because I am what deleting. So it's going to be an empty dimension like that. But just know it's the dimension for columns. But the structure is that you need to place it there. So you need to say delete what a container or a dimension from this. And then now we're left with what dimension? The rows dimension. So now all I need to do is say delete the rows dimension from what? From this array world, like this. And then I'm done deleting or deallocating memory. And then before I leave, before I leave this function, I'm going to make the array point to nothing. Remember, it's an array of pointers. So whatever it was pointing to, it was pointing to integers, right? So I need to make sure that it now points to nothing. It doesn't point to anything because we have no use. We have no use for this two-dimensional array. It's no longer in existence. So I'm just going to make it point to nothing. And then that's the code there. So we've been writing a lot of code and not testing. So let's test. So I'm going to say int arg, which is the number of arguments, and then character pointer arg value, which is the value in the command line. And then I'm going to go to my command line and put in the command line arguments. So what are the program arguments? How many rows and columns? So let's say 12 by 15. So 12 rows and 15 columns. Yeah. Then I'm going to have chances, right? So the infection chance. Yeah, I'm just going to play around with it. So let's say it's 2%, 3%, 4%. Yeah, I'm just going to leave it like that. The number of features for each type of character. What are the number of features? So let's just say they're all the same, right? So let me just say I have 3. Okay, sometimes you need to make sure the size can accommodate all those features. So let's think about it. 369. So you're going to have 9 features. So yeah, I think it should work. So let's say 333, like that. So I'm going to have 3 features for each character. It's going to be 3. Each character is going to be 3. There's going to be 3 of them in the game. So I'm going to have the rows, columns, and the chances and the numbers. So how many arguments are those? It's 3, 6, 8. So it's 8 and then plus 1, the name of the what? The executable, the name of the executable. So that means it's going to be 9. So I expect argc, which is the argument count, the number of arguments, to be 9. So if it happens to not be equal to 9, then we have a problem. So I'm going to say if the number of arguments is not equal to 9, then output an error message. Yeah, it's a very long error message, but I won't go into the details. So I'm just gonna keep it short. Number of arguments less than 9, because yeah, it happens to be less than 9. And then I'm just gonna start on a new line, and then I say restart. Okay, enter. Okay, enter command line arguments starting with, and then you specify the name, the executable. So I'm just going to say the executable, which is, and you can access the values of the values that the values are in the command line by using argv, because argv just basically stands for argument value. So at index 0, because remember array start at 0. So at index 0, which is the first command line argument, it's always going to be an executable, the name of the file. So that's why I'm saying starting with, and then I index I index in my array of strings at index 0. And then we start on a new line. Okay, and then I say followed by, I won't specify what you need to type, followed by 8 arguments, keeping it simple, and then I stop there. Because if I have to go into the details, that means I need to mention all of these. I need to say followed by number of rows, followed by the number of columns, followed by chance, followed by this chance. That's a lot. It's a long error message. I'm just going to keep it short. and then exit error argument count, right? Because the number of arguments were not the number of arguments that we expected. And then now we can get the command line arguments, get the command line arguments. So let's get them. So I'm going to start with the int rows. So int rows is equals to, we call our convert to int function, and then argument value at index 1. And then int columns is equals to convert to int argument value at index 2, and then int what do you call it? Well, how did I structure my function? I need to take it in that same order so that it makes things easier. Infection, recovery, and immunity. So int infection chance, right? Convert to int. Wait, I think I made a mistake somewhere. There's something missing. I didn't use the chance. I forgot about that. I didn't use the chance when I was creating the world. So we need to fix that. So int recovery chance is equals to convert to int argument value 4, and then int immunity chance is equals to convert to, okay, I'm placing extra square brackets there. Convert to int and then argument value at index 5. And then I'm going to have int num. What else do I take in? Int num susceptible, recovered, and infected. Int num susceptible is equals to convert to int argument value at index 6, then int num recovered, int num recovered is equals to convert to int argument value 7, and then int num infected is equals to convert to int, no, convert to int argument value at index 8. Yeah, it's a lot of inputs. So now I'm infected, but yeah, we're done with every input. So let's fix our code. So we need to make use of the chance. So we need to make use of what? Of a chance. So what I'm going to do, right? Because I'm going to use the chance for placing all of the features. So I'm gonna put the chance as input into the function, right? The function that places the feature. So after the feature that I want to place, I'm gonna say take in the chance. So int chance, right? And remember, chance is a percentage. So what's going to happen, right, is that I'm going to generate a random row and no, a random value between a specific range. So generate, I'm gonna say if generate random, right? And don't worry about this structure. It makes sense if you understand functions. Remember functions, there's value returning functions and void functions, right? Or no value returning function, right? If me writing like this is because I know it returns a value. So when I pass in a range, right? I pass in a range like this. Okay, it needs to be from 100, from 1. Yeah, if I pass in a range like this, right? That means if that means it's going to generate a random value between that range and give me back that value. So that's why I can pass it the whole function like that. Instead of wasting time and saying int value like this, and then I say, and then let me copy this. And then after storing it, I just say int value. Instead of me doing that, I can just put the function because I'm expecting the function to return something. So I can just say if that function, whatever value it returns within a specific range because it's a generate random function that takes in a range. And then I'm going to say put the curly braces there. So if that value that we've generated is, remember this whole line will generate a value, it's going to give me back an integer. If that happens to be less than or equal to the chance that I'm taking in this function, then place the what feature, because the features are placed based on a random chance, on a percentage. So I'm going to generate a random percentage and say, and check if that percentage happens to be less than or equals to that chance. And then, yeah, that's the improved version of the function now. And yeah, let's just say the percentages have to start from 1, right? So let me go to my create world function and say the chances. We want the chances to start from 1, at least 1. We don't want it to say 0%, at least 1%. And then we scroll down, we place our features, also passing the chance. So int it's what suggestible, right? Int Wait, which one is it now? Because I'm talking about immunity, chance, susceptible, which is the white circles, infection, chance, immunity, recovery. Oh, so susceptible, it's the immunity chance. Yeah, I don't know why they did that. They could have just made things simple and just called it susceptible chance. They could have just made things simple. And then place feature, and then this is going to be int infection chance, right? Comma int infection chance. And then this is going to be a recovered chance, int or recovery chance. And then here, int recovery chance. So yeah, I just forgot to place that there, the chance percentage, but everything should be fine now. So let's call the functions. So let me create my game world, and it's going to return a game world. So I'm going to say game world, rec world. I'm going to store the answer, right? Because it's going to return something. And then I'm going to say create world, and then I take in all of these things. It's such a drag, I know, but yeah, you have to take them as inputs. So int rows, int calls, and then int infection chance, int what's the other one? Recovery chance, and then int immunity chance. And then what else do we take in? The number of susceptible, int num susceptible, and then int num, what's the other one? Recovered and then infected. Int num recovered and int num infected. And then semicolon, don't forget the semicolon. Okay, let's print our function, our game using the print world function. And then I'm going to remove this. And then I'm going to call the delete memory function. And then I'm going to pass in that record structure. So we have our game now. So let's check. Okay. Oh, clear. Okay, it's complaining about clear. Yeah, I keep forgetting about the clear. I need to say CLS because I'm using 64-bit. Okay, yeah. We took in this, and that. Okay, but it's not displaying the features. So let's debug and see what's going on here. Okay. So let's go to our print world. So there's our print world with array there. there's the features array. What did I call it? I think I used the wrong type. Yeah, I said int instead of char. So it converted these things into integer. So it looked for their integer equivalent values. Yeah, that was my mistake there. Yeah, so now it's fine. But it didn't place the other one. Or maybe we need to sort of like increase the percentage. I don't know, but yeah, there's one that keeps on missing here. Okay, let's do that. Okay, so let's increase the features a bit. I'm gonna say 3, 3. Let's say no 5. That's a bit too much. Let me say 6, 6, 6. Okay, to be honest, any number should be fine because we're placing them based on a percentage. There's a chance of it occurring, so it might not occur, and all of them are not going to occur. You see, so far you only have how many features? Like 3, and you're supposed to have like 8 of each because of that chance. Oh, and yeah, yeah, I see. It keeps on generating the same thing. I forgot to see it in the random function. So srand, right? And then I'm going to say time function, and then I'm going to say null pointer. Okay, there's no need for it to do this. It'll still work, but there's no need. Okay. Okay, there it is. There's a chance of them occurring, and if that chance is not fulfilled, they might not occur, as you can see. Sometimes, and it seems like most of the time, they're not occurring. So I need to change my percentages, I think. Increase them a bit. Give it higher odds. So let me say 25%, 25%, 25%. So 25% each. There's a 25% chance of them occurring. Yeah, you see, now they're a bit more. So yeah, the higher the chances of them occurring, the more they're going to occur. So I want them to be a bit more. So let's say 35. That's the highest we're going to go. 35% apply. Yeah, it's a bit better now. Yeah, it's a bit better. Yeah. So we fixed that. So let's do the movement. And there's also radius and things like that. That what is it? Is it the range or what do they call it? Yeah, the radius, infectious radius. So let's see. Let me see. Okay, I need to start in my header file and create the update, the move, yeah, the move function, movement. So I'm going to say move, I don't know what to call it. Move what? Non-player character. So let me say move NPC. Move NPC, right? And then since I'm moving, I'm going to make changes. So I'm going to say end rec world like this. And then I pass in the reconstruction. And it's moved randomly, right? So I don't need to pass in a movement here. I don't need to do that. It's random. It's not being typed by the user. The other games that you guys have been doing, it was being typed by the user. So let's move NPC, non-player character or non-playable character. So yeah, you can't play that character. So you can't move the character, like physically move the character. It's just you can do it randomly. That's another way of moving it. So let's see. Each character moves one step in a random direction, including diagonals. it is also possible for characters to stay still. Yo, I hate the diagonal part. So let's see. There's a cumulative chance of becoming infected for each infected character. One square within 1 square radius. So it's a 1 square radius. Okay. So let's look at the movements, right? Let's write down the movements, because if you don't write them down, I'm definitely gonna make a few mistakes. So let's see. So this is how you move, right? Let me just say we have this game. This is the game, right? Imagine we have a player that we can move ourselves. Then there's the player there. And then this is row 0, row 1, row 2, row 3. And then press enter. This is going to be column 1, column 0, column 1, column 2, column 3, column 4. So this is our game, right? So now we're gonna find how to move the player. So let's say you want to move, okay, let me say move up. Let's start with up. So remember the current coordinates of the player. It's in row 1, as you can see, column 2. So those are the current coordinates. So current coordinates, it's row 1, column 2. Those are the current coordinates. So to move up, basically I need to find the coordinates. What are the coordinates of this position? Because that's the position I want to move to, which is moving up. What is the coordinate for that position? It's in row 0, column 2. It's in the same column. So now I need to ask myself, from my current position to the position that I want to move to, what changed? What did I update? Between the row and the column, which one did I update? Did I update both or one of them? And by how many units did I update it? So if you check here, it's row 1, you moved, it changed to what? Row 0. So is 1 changed to what? 0. How does that change? I just subtracted 1 from the row. That's all I did. I just subtracted 1. So that means I'm going to say row minus 1. That's how I move up. I'm going to use the current coordinate. Look, just attention, make sure you understand, because current coordinate is what we are using to move, because it's that character that we are moving. So I'm going to use that to move. That's the row that I'm using. It's the row of my current coordinate for that current feature. So moving down, move down. How would you move down? Moving down, if you check, it's in row 2, column 2. So what changed? It's the row. It changed to row 2. So it increased by 1. So that means I need to increase the row by 1 so that I can get row 2, right? And then move down. But this is the general formula. It's that row of the current features coordinates. I add 1 to its row. And then moving left. Yeah, I think you get the gist of it. It's fairly straightforward. So now let's move left. It's still row 1, but now the column has decreased. So I'm going to say column minus 1. Then move to the right. How do I move right? What is increased? It's the column. It increased to column 3. So the column increased by 1, but it's still in the same row. So the only thing that changes is my column. So column plus 1. And mind you, this can be abbreviated to just row plus plus. It can be abbreviated to that. It means the very same thing. Okay, this is row minus minus. We are subtracting 1. And then this means the same thing as column minus minus. And then this means the very same thing as column plus plus, can be abbreviated to that. So now I want to move diagonally, right? So the way I can move diagonal, right? Let's say I want to move this. This is diagonal. I can move there, I can move there, I can move there, I can move there. So it's basically moving at the corners. That's how I can phrase diagonally. So I can move at this corner, or to that corner, or to this corner, or to this corner. Let's for example, let's take a look at this corner. This one over here. How would you move there? What are the coordinates? Look at the column. I'm currently column 2 and it changed to column 1. So I subtracted 1 in the column. And then it changed, and then you, you can look at the row. The row is what is it now changed to row 0. I'm now at row 0. So that means I also subtracted the row by 1. So you subtract the column by 1 because it changed from column 2 to column 1. So that means it decreased by 1. And then it changed from row 1 to row 0, which means that it decreased by 1. The row also decreased by 1. But the way I'm going to phrase it is that I'm going to say you can move up, and the way you move out, the way you make these movements, right? You can sort of like break it down into pieces. So what's the first movement that you can make? You can move up first. So you can move to row 0 first, right? And then you move to the left. How do you move to the left? You subtract the column, of which you've achieved this thing, this movement, or this ability to be able to move diagonally. You've achieved that by breaking it down into pieces. First, you can either approach is fine. You can use any approach. You can say subtract this and then get there. You can do that, but the way I'm going to phrase it, I'm going to say you can move up first, right? You just move to this coordinate and then move to the left. And you can move up and then move to the right so that you can get to this coordinate. And you can move down and then move to the right and get to this coordinate. And you can move down and move to the left to get to that coordinate. So that's how I'm going to phrase it. And when I phrase it like that, you're going to see that we're going to make use of these fundamental movements, the easy movements. So I want to move up and left, right? So I want to move to what? This coordinate. So I start by moving here and I move here. So how do I do that? You subtract the row by 1. The column hasn't changed. The row is still the same. So that means the player moves there, right? I start by subtracting the row by 1. And then I move to the left. So now the player moves to the left like that. You see, I've moved diagonally. So I've moved from this position to that position. So that's why I'm saying you can move up and left. So now what I'm going to do is I'm going to take the formula for moving up and the formula for moving left and do them simultaneous. So what's the formula for moving up? It's row minus minus, which is what I want to do. I want to subtract the row by 1. What about moving left? It's column minus 1, which is exactly what I wanted to do. So that's how you make the movements. And then I'm just going to write the rest. You can move up and right. So we're going to have this move up and right. So up is already this, right? Subtracting the row by 1. So what is right? There's right here. That means it's the column plus 1. So I'm just going to take this abbreviated version, column plus plus. Now I want to move down and left. So moving down, which one is down? It's this one. So it's going to be row plus plus. And then left, how do you move left? It's this line. So I'm going to say column minus minus. Then the last movement, move down and right. So we're still moving down, so it's still row plus plus. Oh, come on. And then we're moving to the right. Where's right? There's right, which is just column plus plus. And then there you go. These are all your movements. So now what I'm going to do is I'm going to copy all of these movements. Okay, don't do that. So I'm going to copy all of those movements. I'm just going to cut them like this. And then I go into my game. These are the movements, right? And then I'm going to make a comment like this. Okay, let's just remove this. and then leave it like this, right? So that I can refer to these nodes, the formulas for moving the player or the characters. So let's do that. So let's see. I need to the first thing that I need to do, right? I need to find the features coordinates. So before we create a find player or find feature function, let's create a function that checks if the movement that you've made is still within the world. So I'm gonna call it is in world. Okay, it usually gives me problems. Let me just declare it there at the top, above the move. No, above the move NPC function. So it's going to return a boolean true or false. So that means it's either it's true that you are still within the world, or it's false that you are within the world. And by false that you're within the world, it means that you're not within the world. So I'm gonna take in game world, rec world, the record structure, right? Because I'm gonna need the rows and the columns. That's how you can check if it's within the world. You just check if it's within the range of my rows and also within the range of my columns. It's that straightforward. So what do I want to check? I want to check the destination row and the destination column. So int d row and int d column. So it's the destination row and the destination column. Those are the two things that I want to check. So I'm going to say return a Boolean expression, right? Return what? Return the truth value of this is int d row, the destination row, greater than or equals to 0, and int d row less than record dot int rows. Is it within that range? Once we're done checking this, we can check the column now, which is the very same formula. So I'm going to say, okay, I need to put more brackets there. If int dcol is greater than or equals to 0, and int dcol is less than record dot int calls. And then I'm going to put brackets there to close everything, to enclose everything into one bracket. So there we go. We're just checking the range there. Is the destination row within the range of the columns? Which means that it's starting at what? 0. It starts at 0 and it's less than the number of rows. Same applies to the column. It's greater than, it starts at 0, it's greater than or equals to 0, which means that it starts at 0 and is less than the overall number of columns. That means it should be within the game world. So we have that is in world function. Now I need to create a find player or find feature. Let's call it find feature. Find feature. Okay, let me just call it find player. Let's just leave it as find player, even though we have non-playable characters, but they're still players in our game. So find player, what is it going to take? It's going to take in a game world, record structure, rec world. What it's doing is finding a player, so I don't want to make any changes to the record structure. All I want from the record structure is the number of rows, columns, and the array, because the feature of the player is within the array, right? But I don't want to make any changes to it. I just want to find it. So since I want to find it, I want to be able to keep track of its coordinates. So I'm going to pass in two variables called int row and int column, so that I know their coordinates. Int column. And then, okay, and then which feature we're trying to find, because remember there's more than one feature. And we're not just finding one player. So since I'm finding more than one, This is a bit, this is an improvement to the find feature, find player function. So you add the feature that you want to find now, because it's random movement. So I'm gonna need to keep finding the feature. Find this feature, find this feature, find this feature, do this, do that. And then we move, right. And then we're gonna move the feature. So let's see. I'm going to say for each row, because I need to go through my whole game and find the feature. That int rows, and then row plus plus. Then for int c is equal to 0, c is less than rec world dot int columns c plus plus. And then I do an if statement to look at that specific coordinate, right, in my game world. How do I do that? I say rec world dot array world, that's my game world, in that specific coordinate, which is row and column. If it's equals to int feature, the feature that I'm looking for, remember the feature that I'm looking for, that means it's that row and that specific column. So I'm going to store the row and the column, but within this if statement. If this condition happens to be true, then within that if statement, store the row for that feature. Int column is equals to c. Then there we go. We found the feature, and you store its coordinates. So, and yeah, and we have more than one feature, so I'm gonna have, and it's going to be random too. I'm gonna have more than one feature, and yeah, it's a bit demanding for the brain, but yeah, it's doable. So we're going to have int, remember that we usually have int d row like this, right? And then it's, okay, not int d row, int p row first, like this, and then int p column like this, right? And then we call find player function, right? And then you say record, what does it take in? Int p row, because that's the variable that I want to store the coordinate for that player. And then int p column, that's the same variable that's going to help us store the features coordinate. And then the next thing that we're going to pass now, an extension of the function, it's the feature that we're looking for. And then we'd say, for example, player, if we had like only one player, but now it's a bit different. We have more than one feature. So that means I need to repeat this 3 times. Yeah, I need to repeat this 3 times. So let's say we find in the successible first. So I'm going to call this int s row, int s column, because the successible. That's how I'm going to distinguish between the three. Successible int s core, right? And then I'm going to copy this, repeat it there, copy this, repeat it there. And then what are the features? What are the other two? It's a recovered and infected. So recovered int arrow, that's for recovered. Int arrow, recovered row, and int r recovered column. And then this is going to be recovered. That's the feature that I'm looking for. And then infected, int I row, int I column. Int I row, int I column. And then we're going to call it infected. And then after doing this, I need to have destination variables, because I don't want to lose track of its previous location. Because if you look at this is why I need destination variables. Because what happens, let's say I've moved there, right? If I don't keep track of its previous location, I won't be able to change its previous location to be an empty space. I won't be able to do that. So that means I need basically 4 variables to keep track of 2 coordinates: the destination and its current location. I need those 2 variables, because once it has moved to that destination, that's its new current, right? So that means this becomes the old or the previous location. So I'm going to use those variables to index to its previous location and then change that to an empty space like this. So it's going to be important that I also have destination variables to store the destination column and destination row. And I need to have this for all of them. So I need to have, since there's more than one feature that I'm moving. So you're going to say int D for destination, right? Row. But it's a destination row for what? The successible. So int SD row. Just gonna call it that. Int SD column. Because it's 0. And then I'm going to repeat, okay, and it's not equals to 0, it's equals to this successible's current location. Because remember what I said when we were looking at this row, this movement, we looked at this current coordinates and then we made changes to those current coordinates. But once I make those changes, I also don't want to lose its coordinates because I'm going to have a problem like this, of which I don't change its previous location to an empty space. I'm going to have that problem. So in order to avoid having that problem, I'm going to have two variables that keep track of its destination and its previous location. And I need to do this for all the features because I'm moving 3 features at a time. And then I'm going to have this there. And then I'm going to change, this is recovered, right? I'm going to change this to R, R, and then this is going to be int R row. Come on, then int, wait, I repeated row there. It's supposed to be column. S column. Yeah, int S column, int SD co, SD row, int R row, int R column, int RD row, RD co. Yeah. And then I'm going to have int I, and then this is going to be int I row, and then int I column. Then there we go. Now we move the player, right? And it's going to be random. So it's going to be random. Oh, so since it's random, yeah, to be honest, since it's random, that means I don't have to worry about these movements. I don't have to worry about incrementing, doing all the, I don't have to worry about that. It's random. I don't have to keep that in mind. But yeah, just keep that in mind if you do have a player in your game. And that player is the only one who can make movements. So let's check a random movement, right? So wait, if it's a random, wait. I think there wasn't even a need for me to do this. Let me think. If it's a random movement, so each character independently moves one step in a random direction, including diagonals. It is possible for characters to stay still. Yeah, it's possible for them to stay still. Characters. Okay, and then the simulation. Okay. So let's see. With movements, how can you make it move randomly? We can generate a random row and random column, but oh, so yeah, I think we can do that. Just keep moving them randomly. Keep moving them randomly. Okay, I see. So yeah, we'll do that. We do it randomly. And since we're doing it randomly, that means I also don't have to find the feature. Yeah, yeah, it was a waste of time of doing that. But yeah, now you know it's good revision to remember how to find a player and the procedure behind it. So what I'm going to do now, let's see. Okay, let's start with this one. Oh, okay, okay. Let me think about it. Let's see. Oh yeah, okay. To be honest, I think it is fine. Yeah, because yeah, even though we're moving it, yeah, we actually need to find it. It's fine because even if you place it randomly, let's say I don't move up there, right? It gets placed randomly. No, I need to do this. It gets placed somewhere here, and it moved from there. So I need its current location, right? So that I can use that as my its previous location, so that I can change its previous to an empty space. So I'm also gonna need that. So finding the features was actually fine. The only difference is now the destination. I don't start there. It just starts at 0. Oh, no, it doesn't start at 0. It gets generated. Yeah. Now I see the flow. So it gets generated between 0 and recworld.intRows -1. So it gets generated, right, randomly. Remember the destination. Destination is where you're moving to. So it's going to get generated randomly. So dot int calls, right? Int calls -1. So the player is moved randomly. This is the sussistable's random location, right? And then now I'm going to move the feature to that location, right? Let me see. Are they going to move for a specific number of times, or let me see. It just keeps moving randomly, right? Oh yeah, so since it's moving randomly, okay, I'm going to delete this. We might need a while loop because this is just moving once and it shouldn't just move once. So I'm just going to use the while loop for that. So it's going to keep moving randomly. You're going to see the magic. So I'm going to say while true, right? Okay. Uh, yeah, it, it happens a lot when you know a lot of languages. Yeah, I was using the Python syntax there. Yeah, it's true in small cases, lowercase. So we generated a random that, okay. And then I'm gonna do the same thing for, okay, I'm just gonna copy for the other features. Do this, and then this one becomes this, and then a random column. I'm gonna call that code, and then paste it there. Okay, and then for this one, the last one, paste it there. So there we go. We've generated its random location, right? They're being randomly moved, right? Remember, it's a random movement. We will take in another variable that will make this while loop stop. Or yeah, there's gonna be conditions that's going to make the game stop. We'll check the conditions later. We haven't done updating yet. So for now it's just movements. So let's see, randomly moved. Let's place let's check. Yeah, this is going to be a lot of code, Shem. Check if is involved. Let me see. Should we really? Okay, but yeah, they said you should check if it's involved. The characters may not leave the environment. That's what it means. May not leave into the environment. And they may not move into each other. So I also need to take that into account. So I need to make sure, yeah, you need to make sure after you've moved that you don't move into an already occupied space. Yeah, this game wasn't playing around, you. So let's say while loop, right? So while rec world dot array world that random um successibles destination row and destination column. int SD call while it's equals to, let's say I've moved into a recovered feature, or I can move into one of them, right? So I moved into that, or int SD row, and then int SD column moved into an infected. Yeah, so I can either do that. I've moved into an infected or a recovered. What should happen? I should generate a random row and column again. And then it's already declared, so I don't need to say int again there. So I just remove the integer, the beginning. So, and I also need to check if it's within the world. Yeah, so it's a lot. So let's check if it's within the world. If is in world, and it's going to take in rec world, right? Record structure and the destination row. So int sd row, then int sd column. That destination row and destination column. If it's within, then what should happen? Move. Okay, change the destination from empty space to a suggestible feature. So now I need to update. So now I know I haven't moved into a recovered or an infected. So now I need to do what? Move to the destination, remove that empty space and replace it with the suggestible. So record dot array world for that destination. So is the int sd row and int sd column should be equals to the destination, right? Remember, it's int sd is the destination, should be equals to a suggestible. And then update the previous location, update the previous location, update the previous location where the suggestible was, basically where the suggestible was, which is stored in int s row and int s column. Update it to be what, an empty space. So we've done that, we've moved, and I must do this twice again for the other features. So what I'm going to do, right? I don't advise you doing this. I'm just gonna copy this. Come on. I'm gonna copy this and paste it. Okay, let me just put comments here and say move the recovered feature so that you know where one movement starts and where the other movement stops. Then I'm gonna do that. Move the infected feature. No, come on. Come on. Okay. There we go. Yeah, most of it is just copying and pasting, just repeating the same thing. And then here at the top, I'm gonna have a comment that says move the suggestible, move it there. Yeah. So we're done moving the suggestible, right? So now I want to move the recovered, right? So I need to change a lot of things. So int rd. Okay, so I'm just gonna put an r there. I feel like that's faster. Rd call, no, Rd call there. And then, okay, for this part, okay, it's still fine. RD row RD core. Did I change everything? RD row, RD row. That's fine. Okay, and then here I need to change this to RD. Then RD, RD, and then R row, R column. Int R row, int R column. Yeah, that's fine. And then with this one, I just need to replace it with i's. So int I d row and int I d core, int I d row, int I d core, int I d row, int I d column, and then int I d row, int I d column, int I d row, int I d column, int I row, int I column. So now I need to make sure that I'm also looking at the right features, because here at first it's a successible, right? I can only move, occupy, let's say I happen to occupy spaces that are occupied and I'm trying to place a successible. I can only occupy the recovered and infected, right? When I move to the recovered, I can only occupy infected or the successible, right? So I need to update that. And then when I move to, yeah, I also need to update what I'm, this destination, what is it going to be? Yeah, I copied and pasted, so I need to make sure that I also make those necessary changes. So I don't make that as successible, I make it a recovered, because what am I dealing with here? It's a recovered. And then I check this one. It can be, I'm placing the infected, right? So it can be a recovered or a successible. And then I want to change the destination to be an infected since I'm now moving the infected. So yeah, this is the whole code for the movement. Let's try and move. It should it should move and not occupy spaces that are already occupied. So I don't need to create. Remember that we are not getting inputs from the user like move and what. We're not getting all of that. It's just an automated thing. So, and I already have, if you check in my code, don't I already have that while loop, that do while or while loop, whatever. We can use a do while if you want to for the conditions. We might have to change, but for now I'm just going to make it a while true. So we're just going to run infinite number of times. So npc rec world, and what is it? What else does it? Oh, it only takes in a rec world. That's it, because we're not getting movements from the user. So let's see if it's going to oh, it's repeating the movements. So let me see something. Let's just make it, because now, oh yeah, it needs to repeat printing and stuff. So okay, we actually do need it. So BLN continue is equals to true at first, and then do runs at least once, then checks the condition after. So while true, do these two things. So keep printing and move. Print, move, print, move, print, move, print, move. Stop and rerun. Okay, something is not right here. Wait, let me think about it. There's more than one. Yeah, I think I know why now. Yeah, if you think about it, the code that I wrote, it only finds one of them. And when you say find, right, let's think about it. What would happen if you have more than one feature and trying to find it? Which coordinates would it give you back? That's the question. Which coordinates would it give you back? Because there's more than one of these features. Yeah, there's more than one of these features. So let's see. Yeah, let's think about it. Let's see. Okay, so if that's the case, let's just say, let's just do it like this. Let's just remove the while loop. We're gonna use this loop here for the repetition. This one, the do while. I'm gonna use that. So I'm gonna remove this. Need to remove this extra curly braces. So let's see, let's think about it. If you want to move features, right? There's more than one, that's the thing. You want to find that feature. So let's say find player, it's the find player, right? It's going to find suggestible, this thing. Hmm. It's only going to find one. That's the problem here. Okay, it might find, yeah, if you think about it, it might find, but it's going to find, it's going to return the maximum, basically the last features coordinates. That's what it's going to do. And we don't want it to do that. So what we can do is we can place this, let me see. Yeah, we can place this in sort of like for loops to repeat. I think that's the trick we can use. Yeah, I think that's the trick we can use. Okay, I think that's the trick we can use. Because if I place it in a for loop, what's going to happen? It's going to repeat that code for that specific number of times, which means that it's going to repeat it basically for what? For all the features. So I'm just going to use that to my advantage. So let's say int s is equal to 0. S is equal dot int num suggestible s plus plus. Then within that for loop, it's going to repeat this for the space for all suggestibles, for all of them. And then it keeps moving them, keeps moving them, right? And then I'm going to do the same thing for this one. No, I didn't want to delete that comment. So we're going to do the recovered. So int r equal to 0, r is less than or equal, but int num recovered. Remember, the numbers, we stored them inside the record structure. That's why I'm able to retrieve them. Yeah. And then I paste the code that moves each uh each feature, each recovered feature. And then here I'm going to have infected. Int I is less than rec world dot int num infected I plus plus. Let's see. Yeah, I think that should do. Or at least have something a bit better now. Let's see. Yeah, yeah, now it's fine. You see, the problem is that it was finding one piece, and there's more than one piece in the game. So what I'm doing is that I use a for loop to count all of the pieces, right? because I know, because with that number that I stored inside the record structure, I know exactly how many pieces are there. So I can use that to my advantage, do a for loop and say, repeat this, find each feature at a time. So it's going to find the first feature, and then it moves that feature, and then finds another feature, and then moves that feature. Yeah, so it needs to be something like this. And I think it is moving everything, right? Okay. Why is it so long? Why is it not deleting the previous? So let's see. It is somewhat doing what it's supposed to do, but I feel like it's not 100%. Let's see. Let's see my find feature. Mm, let me see, find feature. Okay, let's think about it. Find the feature, find the feature. Because I feel like it's not doing 100% what it's supposed to do. Because here it's still doing the same thing. It's only finding the last, the code that we need to fix to here is this finding. It needs to stop, it needs to stop finding a feature that it already has found. Yeah, it needs to stop finding it. So how do we regulate that? Make it stop finding features that it already found, or what we can do, right? Yeah. Yeah, I think that's the best way to do it. So what I'm going to do, right? Yeah, now this code is gonna look so complicated. But yeah, let's do this. Let's do it like this. So instead of having all of this move what players, right? So let's start with this one. So what is going to do, right? It's okay. No, I need to have it outside, my bad. I need to have it outside like this. So it's going to be like this, right? So it's going to be a for loop. And then I'm going to have if statements. I'm going to say if it is equals to that this feature, then move that feature. And I'm going through all of the features like this. Then I need to copy and paste that code inside and move the feature. And then once I've moved the feature in the previous location, I also need to do those things here. But I already have the code for that, so we don't have to worry about that. And I don't have to put it inside a for loop like this to go through all the number of susceptibles or the number of infected. So let's fix that. Let's say if I found a susceptible, those are the coordinates, right? So let's do susceptible first. So let me copy this D and then do this. So now the susceptibles rows and columns, right? It's this within the if statement, it's R and C. So now I don't have to keep track of this. So I just need to remove this code. I don't also need to find the player because I already know where the NPC is. But the random row and column I need to generate. That's non-negotiable. So the only thing I need to change is R, change that to R, and then change this to C. And then I do the same thing for the other features. So I'm going to have this, and then okay, it's here, else if it's equals to recovered, right? So if it's equals to a recovered, okay, let me document my code so that when you guys go through it, you don't get lost. So I'm gonna put this there and then do that. And then remove this for loop. Then copy this, comment here, and then I edit here before I start coding. Come on. Why do you have to do this? Yeah. And then let's copy this code. Yeah, I don't know why I didn't think about it this way, but yeah. This way is way better. And then now this becomes R, remember? C. Because once I've used that if statement, it means that if any code within this if statement, it means that that's that features, for example, recovered. This is the features rows and column, the features coordinates. And I'm gonna move each feature. So I'm gonna do and you see it's going through all the features. That's why I have those two arrays there. Two for loops, I mean. And then, yeah, that's it. We've done the necessary changes. That's recovered, right? This is recovered. Yeah, it's recovered. So now I need to come here and say else if, okay, else if, okay, where does this one end? Damn, okay, yeah, I'm already having missing curly braces, extra ones too. So let's continue. Let's see. Now I'm left with the infected. So I'm gonna copy this comment, then I paste it here. Still, it doesn't want to be. Yeah, and then we copy the code for. Come on. Copy this code for placing for moving the infected feature. And then there we go. And then I change this to an R, change this to a C. It's infected, right? And then I don't need to find the player anymore. Generate a random row and make sure I don't place another feature. If that random row is within the world, then move. If it's not, then don't move. Yeah, I think this is a bit better now. Let's run it and see. Yeah, nah. Extra curly braces and stuff. Let me see, where does this one end? It ends on that function, okay. So that means I need an extra one there. And then this one, where does it end? Yeah, it does end on the namespace. What's missing now? Oh, it's the, okay, yeah. This needs to be on its own like this. So that means this function is missing curly braces. Yeah, it is. So I need to put an extra curly braces there. And then there we go, the area is gone. Yeah, it's a lot of code, a lot of validation. There we go. I think everything is moving now. Exited with one. Yeah, it is moving, but I feel like some features end up disappearing. Yeah, some features are disappearing. But yeah, this is how you would approach it. This is how you would approach it. Uh, Let me see what could be missing this side. if it is a random row and a random column, let's check. It is making the changes. I am passing it by reference. If it is equal to a successible, then move the successible and replace its destination with a SD core. And the destination is a random row and a random column. If it's within the world, obviously it's going to be within the world though. Okay, it's either with my validation or something like, let me see. Oh, I think I kind of get it. I think you might also have a situation whereby you're trying to move a feature in the same location that it's already occupied. Yeah. So like this, let's check dot 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 like this, right? Then enter, 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 enter. So you could have something like this, right? And then you have another feature right there, right? I see what's going on now. So you have another feature there. So now you move this one and the random location is this. What's going to happen? It's going to delete that one and then replace this one with the feature. So now what's going on? That one is this one is missing now. Because now this one that's here, it's the one that was there. So now I need to check. I also need to add an extra check to make sure that I'm not placing on top of itself. So I need to add another or for all of them. So or world dot array world, and okay, I don't need to type it out like this. So we only want locations that are empty spaces, no other location. Because if I leave it open-ended like this, it means that I can replace another successible. And I think if you check, they will not move into each other and things like that. So you need to also take that into account. And then we do the very same thing here with the recovered. So if I've moved in either one of them, even itself, then that's a problem. So you can either run into successible, infected, or recovered. Wait, yeah, yeah, I saw another error here. I'm saying recovered here instead of infected. Yeah, yeah, that's another problem here. But yeah, that one, the problem that I just raised right now, it's also important. I don't want to move into the same location that's already occupied by the same feature. So infected, I wasn't checking infected, so it was being replaced too. So infected, so it's equals to an infected, so I need to say or then record this and then say it's equals to an infected. Okay, infected. Yeah, so it can occupy space that's already occupied by another infected. Same applies with the recovered. It can occupy space that's already occupied by another recovered. Same thing applies with the successible. It can occupy another space that's occupied by another successible. So I think it should be a bit better now. Yeah, now all of them are moving. You see, there's no features that are disappearing. This is how you'd move it. I know it's a lot to take in, but if you saw how the approach that we did, it was step by step. You break things down step by step. We started with what? By writing a notepad like this we wrote it down step by step that I'm gonna have features here, and then let's say I have a player there. Feature. We wrote it down step by step. So what happens when I move into that location? What happens? I need to replace its previous. So I need to keep track of two coordinates. The player's current row, right? And the player's current column. And the player's destination row and the player's destination column. So there's four things because each coordinate, each point in the game, it's a coordinate. It's made up of two values. So I needed to make sure of that. So we broke it down step by step. And then at the end of the day, what do we have? We have the game. It's doing all the things it needs to do. And then there it is. There's the game. So I think that was the main problem with the movement. Yeah, I understand. You see how much code you'd have you have to write in the game. It's a lot of code. So I don't know. Do you guys have any questions? Because I think movement was the important feature of the game. Because now with update, a susceptible has a cumulative chance and becoming infected for each character. Um, for each character within a 1 square radius of each other, the base chance is specified on the command line. What basic chance are they talking about here? So we also need to add an extra chance as input. Yeah, I think you also need to add an extra chance as input. A susceptible or covered character has a cumulative chance of becoming infected. It's either that or infection chance. Hmm. I see now. I see why there were a lot. Okay, so we misinterpreted the question. The chance, to be honest with the chance here, I think the chance what they're trying to refer to, okay, a fixed chance of recovering. Yeah. So that chance, right, that percentage, it's not actually the chance of it being there in a square. So you don't have to worry about the chance. So the chance is for the updates, for the updating part. That's the chance. So we need to do a lot of fixing here. So we can remove the find player because we saw that it wasn't necessary because we're moving every feature. And since my game is gonna have the chance, the features are going to be all there. So I'm gonna have 8 each, right? So let's go to that function. Where's the function for place feature? Where's the place feature function? Yeah, there it is. So I don't need to generate the place it based on a chance. That chance that they gave you is for the update function. So when you have to update, you use that chance. I think it's either decreasing, I don't know, based on the requirements. So I need to remove the chance. I don't need it anymore there. So since I don't need it anymore, when I call these functions for placing the feature, I need to remove it like this. Then there we go. And now I'm gonna have all of the features in the game. Place feature, where is it? Oh, it's still there. Okay, still more lines to remove. Yeah, you see, now we have a lot of features because there's no chance anymore. There's no chance being used to place them. It's just placing the exact number. So that chance, it wasn't, yeah, you see, that's the problem. You shouldn't answer your own questions. Yeah, I just assumed and answered my own question, but that's not what you're supposed to do. So what you're supposed to do was to just place them for the specific number. If they said 4, if you wanted 4, then you place 4. If it's 3, you place 3, and so forth. Then the chances, right, for each, you would use them in your update function. And then if there are no infected, what, if it moves, yeah, you're gonna have logic for that. But do you have a basic understanding of the movements? Do you guys have an understanding of the movements?
Yeah, a little.
A little, yeah, but yeah,
It's a lot.
it's a lot, I know, but just kind of break it down. If you saw how we're doing in the tutorial, we broke it down. So I know a lot was being changed because yeah, I was thinking about the solution and tutoring at the same time. That's why. So I was like I had to keep on changing code, updating, taking the new information and things like that. But it's simple. You just do your two for loops, right? And you go through every single position or coordinate in your game world and you check if it's equal to that feature. We have three if statements to check if it's equal to that feature, right? After I
Mm.
found that feature, what do? I put the code for what? For moving the feature, that specific feature. But remember that its destination and its destination basically, it's random, right? So I need to generate a random row and a random column to move it. But before I move it, while this random row and random column, it points me to a location that's already occupied. What should happen? You should regenerate it again. Then once you're done with the validation, I check if that destination is within the world. How do I check? I pass in its destination row and destination column. And then I use the destination row and destination column to set it to be a successible. That's the destination, right? Because that's where the feature has to move to. And then its current location, which is row and column RC, it needs to be an empty space, replaced with the what? Empty space. And then that's pretty much it. You just do the same code for the other features. Yeah, I know it's a lot, but yeah, do you understand at least the movements? I don't need you to know the code like in your head. That's not really what I'm expecting you to know here. I just want you to know just to know that you have an understanding of how we find how we move the feature.
Yeah.
Yeah, just a basic understanding. So if you have situations like this, right, whereby they say they say a they say what there's non-playable characters, right? It's NPCs, non-player characters. That means there's no one player. You can say that there's multiple players that are moving. Just know that there's going to be multiple movements. That means you must do something like this. And with something like that, you need to make sure that remember randomness, right? It's a random for a reason. It can be anywhere. So I need to make sure that if it's in a location that I don't want it to be in, then I regenerate. And I use a while to say, while it keeps on regenerating, and one of these locations that are occupied, generate again. And then once that's been sorted, I check that random row and random column if it's within the world, that destination where I'm trying to move to. If it's within, then within that if statement, then I make the necessary changes. The destination, basically where I'm going to, I update it to be that feature. It can be a successible or a recovered. And then the previous location, which is basically the location that we found it at. That's the previous location. That's where we found it at, right? Set that to an empty space. That's all I'm doing there. And then I do the same for the other features. You guys understand?
Yeah.
Yeah, we can go through it again. If I don't know, maybe when are you guys writing? Next week Friday,
Yeah.
right?
Yeah.
Yeah, yeah, we can go through it again, like this one, right? And then we go through, let me check something. This practical was 2020 main exam. Damn, this was the main exam. I thought it was I think a sick test or something, or a sub. But yeah, for the updates, yeah, for the updates, they should be pretty straightforward. Let me see. Let's check. A successible or recovered character has a cumulative chance. Okay, that chance, right, within one square. The base chance is specified in the command line. It has a chance of becoming infected. So if it becomes infected, what does it mean? Does it mean we replace it with infected? Yeah, I think that's pretty much what it means there. Yeah, that's what it means. It's successible or recovered. So you're gonna start doing that if statement for chance, right? So you're gonna generate a random uh percentage between 1 and 100. And then if that happens to be less than or equals to that chance, depending on which feature you're looking at, then you should change that feature to an infected character. So you update it to be an infected. So yeah, within one square radius. Let me see. Oh yeah. It's a lot of it's quite some logic, this first part. But yeah, you'll just get back to me if you get stuck, if there's something that you're not understanding on the update part. Because now time is flying and I'm sure you guys have a lot to fix in your code. So I suggest for now you just fix that. Make sure that it's moving randomly and doing all of those things. Do you guys have any questions before I end the session?
No.
Okay. If there are no questions, that's it for today's session. You can just let me know via WhatsApp if